You know what's a great feeling? Launching an app. You know what's really scary? Launching an app. Today, we're here to answer the question, what do I need to know before I launch my Firebase app? My name is Rebecca, and I'm an engineer on Firebase App Distribution.
And I'm DiMarco, engineering lead for Firebase Build products. Let's start with a story. Together, we're building a gaming app. It's a really cool concept. We're excited about it. And we want it to be used by people all over the world. We start by building a functional prototype. We're testing it out with our team. We're iterating on it, and we're fixing all of the bugs that we find as we go along. We think we're almost ready, and so we set a launch date. Still, we're feeling a bit anxious. We've fixed all the things that we do know, but what about all the things that we don't know? Even so, launch day is rapidly approaching, and we go for it. Early signs look promising. We start seeing downloads. We're generating some buzz. People are talking about it. We're feeling really excited.
But then the bug reports start to come in. And on the App Store, we're seeing mixed reviews. We see 5-star reviews that we're really excited about, but we also see 1-star reviews and we feel anxious and scared. Some customers are saying that they really don't like a certain feature of our app. And a handful of others are even saying that the app crashes for them. Then, to make matters worse, a few days later, we get a security vulnerability report. Apparently, users can easily cheat their way to the top of a global scoreboard. It becomes this big joke, and people start trying to poke holes into our app. All eyes are on us.
At this point, we're obviously feeling pretty bummed. We put a lot of work in. We really wanted that launch to go well. But all of these issues were preventable. So what did we miss? That is what we'll be talking about today. We'll give you the tools to gear up for launch and launch with confidence.
So looking back, what happened? We built an app, and then we launched it. But then we started seeing unexpected bugs and bad customer reviews. It seems like our testing had missed something critical. So now, we probably wrote some unit tests. We probably also tested on a few emulators, and everything looked fine. But deep down, we were still wondering what would happen after we launched. So knowing this, how can we gain confidence in the quality of our app? The key is understanding that users have different backgrounds and use different devices. Our users are diverse, so our testing needs to be diverse too. Given that, what can we do?
First, we're going to need real devices. Testing on an emulator simply is not enough to tell us the whole story. Next, consider, what if our users speak a different language than we do, or they use their phone in landscape mode and we use it in portrait? We need to test different situations too. We also can't forget about having a very diverse tester base. We need more users, more perspectives. It would be awesome if we get our app in the hands of real users before going live. Now, we know what we need to do, but it's a lot of work. We're really focused on building something that our users love, and we don't want testing to introduce any additional stress. This is where Firebase comes in. Firebase Test Lab makes automated testing so much easier. Instead of having to go out and buy physical iOS and Android devices, Firebase Test Lab stores those devices in a Google data center, so you don't have to. Instead of configuring emulators for things like different screen sizes, different languages, different locales, and the many combinations of those factors, Test Lab will do it for you. Going back to that example at the beginning, how could we have used Firebase Test Lab to figure out why our app was crashing for certain customers?
So one way we could have used Test Lab is by running a robo test. The robo crawler does a depth-first search analysis of our app. It will go to different screens, click on different buttons, and really try to test all the user paths. So let's go to the demo and see how this works. Thanks, Rob. All right, so now we're in the Firebase dashboard on the Test Lab page for our demo app. We'll start by hitting Run a Test, and we'll select Robo Test. So an error is occurring while loading this page, So we'll try uploading it here. What we would do is upload our APK. it would validate. And then the next page we would see is a device matrix. So on this page, we have the option to select so many different types of physical and virtual devices. And the default selected a few Pixel 2s, but since I'm trying to figure out why my app was crashing, I want some variety, so I can preload a template. And so I will select the Pixel 2, a Pixel 3, and let's just get an older device just to shake it up a little bit. And then at the bottom of the screen, we also have the option to select a different orientation and also different locales if we want to test different languages. We would start by hitting Start 3 Tests. This will take a few minutes to run, so let's just look at the results from a previous example. Can we switch back to the slides, please? All right, so after a few minutes, we would have results that look like this. We immediately can see that 2 of our tests passed and 1 failed. Let's go through the results one by one. Let's first look at the oldest device, the Nexus 5. So here on the test results screen, we see that our test passed. Our robo was successful in crawling our app. But there are also a few different tabs that we can dig into with more information. Here on the first page, we have the crawler metrics. And then if we scroll down to the bottom, we'll see a crawl graph. And this gives us a sense of all the different paths that the crawler took. This is really useful for understanding the coverage of our robo test. But a robo test doesn't just tell us if a crawl was successful, if it crashed or not. On the Screenshots tab, we also have the opportunity to really visualize our app. And we can even see where the crawler interacts with user inputs. On the Videos tab, we get a similar but more detailed view where we can actually walk along the entire crawler experience. Both the screenshots and the video give us a really great sense of how our app looks and feels across different devices. There are 2 more tabs, Log and Performance, that we won't dig into. But those are really useful for debugging issues. All right, so I'm feeling good about the Nexus 5. Let's look at the Pixel 2. So here we see that the Pixel 2 crawl passed, but interestingly, we see a new tab that says Test Issues. Apparently, we're using an API that will no longer be supported after Android P+. API level 28 is Android P, so we're just safe for now, but doesn't this mean it will be a problem for newer devices? We're feeling concerned. And then if we go back, and this time we look at the Pixel 3, let's figure out why it's failing. So our concerns are confirmed. If we dug into the logs a bit more, we'd find that there was a no such method exception. It's because that API was no longer supported. We realized that this is why we were having mixed reviews. Customers on older API levels were fine, but customers on the newest API level were running into this crash. In just a few minutes, with little setup, we found the reason why our app was crashing for our customers.
Robo-tests are really powerful, but we can also run highly customized iOS and Android instrumentation tests. Firebase Test Lab lets us perform end-to-end tests for all our apps in one place. Now that we've run Firebase Test Lab, we're feeling a lot more confident about the quality of our app. But no matter how many devices we test on, automated testing doesn't have context. The crawler doesn't understand what your users actually want to do. We need real users to be able to tell us if the user experience is confusing or unintuitive, or if the app is not behaving how they might expect it to. We need some level of manual testing. That's where Firebase App Distribution comes in. Let's walk through it. Instead of having to manually send all of your APKs and IPAs to testers, App Distribution lets you manage your iOS and Android distributions in one place. In one central location, you can upload distributions, attach release notes, and send to testers. And what's more, you can get started instantly with no SDK. It also provides an intuitive UI for you to manage testers and create groups. For example, you might want to create 2 internal tester groups, one for iOS and one for Android. For the tester experience, when you upload a new distribution, testers get emailed instantly. App Distribution also provides a tester UI, so your testers get to choose which version of the app they want to install. This gives them the ability to easily test different variants of your application. During the keynote, we demoed how App Distribution can be used in the Firebase console and with Fastlane. But you can also distribute iOS and Android apps with the Firebase CLI or with the Gradle plugin. We understand how important automation is for you, and we want to give you the choice and the flexibility to use Firebase App Distribution with the tools that you're already familiar with. Let's take a look at the Gradle plugin and see how it works.
So going back to that example, when we had 1-star reviews and customers didn't like a certain feature of the app, how could we have used App Distribution to get ahead of that feedback? Let's check out a demo. So here, I'm on the Firebase console for my app. I've already distributed 2 versions of my app to testers using Firebase App Distribution. But now I'm ready for version 1.2 because I'm releasing a new feature. So to distribute with the Gradle plugin, I'm in my build.gradle. The first thing I need to do is apply the plugin and add the dependency. Then, in the specific build variant, you can specify a Firebase App Distribution block for the parameters that you care about. In this case, we're specifying a few parameters, including a service credentials file, which lets us authenticate, release notes to let testers know what's included in this new version, and groups and testers, the people who we want to receive a distribution of our app. So now that we're ready, we'll go to the command line and run a command. We're going to first assemble the debug version of our app, and then run app distribution upload debug. So what it's doing is it will upload the debug version of my app to Firebase App Distribution, and then make sure my release notes and testers are also included. I also want to point out that it doesn't have to be the debug command. App distribution is variant specific. We want to give you the flexibility to upload a Firebase App Distribution and have different parameters for different build types and product flavors. So it looks like it uploaded successfully, so let's go to the console and check it out. So if we refresh the page, we should see a new distribution for 1.2. And we do. We verified that it has the release notes and the right testers. And then, if I'm a tester, and I refresh my inbox, I should get an email. But in the meantime, let's look at a previous release. I would get an email looking like this, and I'd be able to open it on my mobile phone and start testing the app. And here, the email just came in. Can we go back to the slides? Awesome. So we successfully distributed our Android app. But I want to point out that we can distribute iOS apps, too, using the CLI tools. Using app distribution, you can address feedback before launch and ultimately be more confident that your app will work in the wild. Also, as you may have seen earlier in the keynote today, app distribution is now in public beta. So go to the console to get started.
Now that we've tested our app, let's move on to validating its security. Think back to that example at the beginning of this talk. That's terrifying, right? If your app goes live, it's growing, it's met with initial success. But that growth and that success also invites additional scrutiny. We all want to get application security right, but this task can seem daunting. For the next few minutes, we're going to give a brief overview of the application-level security model in Firebase, and then show you how to use Firebase tools to validate the security of your app before going live. For many of you, this might be a refresher, but let's start with how to think about security for apps built on Firebase. Usually when you build an app, your mobile or web clients connect directly to services that you control. And then those services perform authorization and authentication checks before they change or mutate data. But when you build an app with Firebase, we abstract much of that infrastructure away. So you don't need to think in terms or keep up with OS level or network level security. With Firebase, we ask only that you think in terms of application level security. But we still need to ensure that only authorized services, clients, and users are able to read or write the correct bits of data. So how do we secure those requests from untrusted client devices? The answer is with security rules. Security rules are the tool used to define whether or not authorization should be granted for requests to your database. We're going to walk through the tools that Firebase offers to help you learn, write, and test security rules.
First, let's see an example of how security rules can be helpful. Let's say I'm working on my new game called Gold Mine. In the game, users collect gold as they go through each gameplay. They also have the ability to compete against each other and place in a global scoreboard. Each of these data types, the users, the gameplay, the leaderboard, has a different security need. Let's dig deeper into the security need of users. So we want user records to be publicly readable, but user editable. This means that only the user themselves should be able to edit their own profile. Makes sense. So how can we enforce this using security rules? Well, writing rules can be complicated, especially if we've never done them before. This is where the security rules simulator comes in. The simulator is an in-browser playground that lets you safely experiment with security rules. You can simulate reads and writes without actually needing to modify your database or having to set up a development environment. Let's go to the console and see a demo of how this works. So here, we've started writing security rules for our app. The first thing we need to do is match a specific document. In this case, we're matching the user document. And then, inside this block, we can write rules to match read and write operations. Let's think about reads first. We want user profiles to be publicly readable. Anyone should be able to read it, regardless of if they're logged in. So we're going to write a rule that's allow read if true. Pretty straightforward. Now let's move on to writes. So for writes, remember, we only want the user themselves, the user who is logged in, to be able to edit that profile. So let's try taking a stab at it. All right. Given my limited security rules knowledge, I think this is right. But how do I validate it? Let's go to the simulator. So here in the simulator, I'm logged in as myself, Rebecca, and I'm trying to update Rob's profile. This shouldn't be allowed, so I'm going to click Run. And the simulator tells me that the write is denied. All right, that makes sense. So now, let's try to edit my own profile. If I hit Run again, the write is allowed. This looks good, so I'm going to publish my rules and save them. Let's go back to the slides.
So now, the security rules simulator is useful for learning and experimenting. But once you start building an app for production, you want to start developing, testing, and deploying rules following the same best practices you apply to the rest of your code base. And for that, we turn to the Firebase Emulator Suite. The Firebase Emulator Suite lets you run our production services on your local machine, including Cloud Firestore, Cloud Functions, Firebase Hosting, and the Firebase Real-Time Database. During the keynote, we saw how the Emulator Suite can be used for local development. But even more importantly, the Emulator Suite is essential for thorough testing. Running locally is super fast, it's free, and it doesn't introduce the risk that you'll in any way harm a running production application. Going back to my goldmine game, let's move on to securing the global leaderboard where users can post their best scores. Using rules, I'm trying to prevent fraud in this game by making sure that users can only share scores for games that they themselves played, and those scores need to match the official gameplay result. No spoofing. let's use the Firebase Emulator Suite to validate this behavior with thorough integration tests. Let's switch over to the demo. Here in my IDE, I've started writing some integration tests for rules to secure that leaderboard. First, I'll start the local Emulator Suite with a single command using the Firebase CLI. With that, I have a local instance of Cloud Functions, Firestore, the real-time database, and Firebase hosting all running on my local machine. As you can see, each time I save my security rules, the Emulator Suite is noticing the change, picking them up, hot reloading those rules, and applying them to my databases. Now let's take a look at my tests. Compared to what the simulator is capable of, this is much more advanced. This is far more rigorous. This test, for example, will clear the Firestore database, bootstrap it with some gameplay data, and then I'll write a test that is going to check to see whether or not a user can share that result with a mismatched score. It passes. Great. But remember, when testing security, always test both code paths, both the access granted and the access denied. Think of this just like code coverage. If we test the if branch, we also need to test the else branch. Adding the complementary test and rerunning, we'll see that we've got a bug. It looks like I've got a typo in my security rule. I'll fix this typo, save my rules, the Emulator Suite will hot reload the change, and I'll rerun my test. All right, it passes. That's what the Firebase Emulator Suite is all about. Rigorous, comprehensive security testing for your apps before launch. Let's go back to the slides.
So at this point, we've corrected all the problems with the initial launch. We're feeling confident. But how do we make sure we launch with confidence every single time? The answer is with automation. Automating lets us maintain stability and security without sacrificing velocity. Building great apps is hard. We've all got things to do. Speed matters.
That is why all of these tools were built from the ground up with continuous integration in mind. We understand how important automation is for you and how important speed is for you, and we want to help you succeed. Let's see an example now of how you can integrate Firebase Test Lab, Firebase App Distribution, and the Emulator Suite together in your CI/CD pipeline.
So here we have an example continuous integration configuration. First, we'll need to download and install the command line tools for Firebase and Google Cloud.
Next, we'll invoke our unit and integration tests using that Firebase Emulator Suite. This lets our security tests run locally, quickly, and in a safe, isolated environment. Running the tests in this way also ensures that the Emulator Suite is spun up fully before tests are run and cleanly shut down after running tests is complete.
Then we can run our Test Lab robo test. In this example, we're testing it on 2 devices.
If all of our tests pass, we deploy our changes to Firebase and distribute the latest version of our app to trusted testers using Firebase App Distribution. If we wanted to, we could customize this further, doing things like distributing different app versions or variants to different tester channels.
So let's summarize. We've built our app, we've tested it, we secured it, we've added automation, and now we're ready for launch. Remember, these app stability and security problems are preventable. Firebase is here to give you the tools you need so you can launch with ease and confidence, the first time and every time.
Go back to your teams, try these tools out, let us know what feedback you have, and how we can help you further. Thank you.